Hello guys, welcome back to Maison African Motives. Still working on mathematics, and for in this case we have got the question paper which was written in March, that is 2023. So we are going to revise along the lines that you are given in this case from this paper. All right, so you're not going to waste much time, guys. We are going to quickly rush through what we are given in this case. So the first part, we were given our instructions, information. So the most important part is you're supposed to answer each question on each part of the paper, and also your answers to 3 decimal places unless indicated or stated otherwise. All right. The first part of the question, very sorry for this question paper, how it looks like, but okay, I hope we can properly see what is given. So we're asked to draw the graphs of y is equal to x to the exponent of 3 and y is equal to minus x to the exponent of 3 on the same set of x's, and that is 3 marks for 6 marks for that. Okay, so this part we could have drawn our table values. If you are not understanding these graphs, okay, so you can just draw your table of values. In this case, for y is equal to plus x to the exponent of 3. We can just have our values of x taken, just few values that you're going to have, not much. All right, so in this case, I'm just going to use x, y. In this case, let's just say we've got -3, -2, -1, 0, 1, 2, and 3. Okay, so let's say these are the values of x that I'm going to apply in this case. So if I substitute here, if x is -3, that is going to be y is equal to -3 to the exponent of 3, which is going to be -27. So yes, -27, -8, -1, 0, 1, 8, and 27, like that. Okay. So with this information, you can actually draw your graph. Okay, so in this case, I'm just showing you as a sketch, but you're supposed to actually draw. So you can just have your y-axis, your x-axis in this case, like this. All right, so that's a 0 here. We've got 1, we've got 2, we've got 3. We've got -1, we've got -2, we've got -3, like that. Okay, so here you can just use any scale of your choice, but the major points is going to be -27. So let's say we've got a -10, a -20, a -30. In this case, the same thing, a 10, a 20, and a 30. All right, so that means -3 is going to be affected by -27, maybe at this point, -1 and -8, maybe at this point, 1 and -1, maybe it's at this point, 0, 0, 1, 1, 2 versus 8. So maybe it's somewhere here, 3 versus 20. So you just mark your points properly in this case, then you can join them. So it's just going to be something of this nature here. So that's how our cubic function was going to look like. All right, so that's for the graph of y is equal to plus x to the exponent of 3. The same thing you are going to apply again for y is equal to minus x to the exponent of 3. Remember, this is on the same axis, okay? So you can have our table again for the graph of y is equal to minus x to the exponent of 3, taken again from the same points or from the same values of x, which is from x is -3 up to +3. So we've got -3, -2, -1, 0, 1, 2, 3. All right. So having our values in this case, we can substitute. So you're going to see that take note, it's there is a negative that is going to affect your answer on each value to say y is equal to minus. If you substitute the value of minus, it was supposed to be -27, but it's going to be affected by a minus. So meaning to say every answer that we have here, we are just going to multiply by a -27. Here is going to be +8. Here is going to be +1. A 0 is going to be a 0. 1 is going to be -1. 8 is going to be minus 8, 27 is going to be minus 20. That is what it means. All right, so having our points in this manner, we are going to see that now minus 3 is corresponding with 27 somewhere here. Minus 2 and 8, that's maybe somewhere here. 1, minus 1 and 1, maybe somewhere there is 0, 0. 1, it's now versus minus 1, maybe somewhere there. 2, versus minus 8, 3 and minus 27, maybe somewhere here, so forth. Okay, so this is how your points are now. So which means your curve was going to be something like this here, up to this point, then to the point of 1, up to this point, something of this nature like this. Okay, so that is how your graph was supposed to look like. Okay, so here, this is just a sketch, but you're supposed to at least draw something nicer and presentable than the one that I'm having here. 1.2, draw the graph again of x. We are given x squared plus y squared is equal to 25. So that's 1.2. So let's see what we are given in this case. So we're given x squared plus y squared, which is equal to 25. By just looking, you can see, okay, this is a circle, guys. You are supposed to know also your equations, all right? So for a circle, we can simply find the x-intercepts where we know that y is equal to 0 at that point. So if y is equal to 0, that means x squared is going to be equal to 25 because here we are now having a 0. So finding the values of x, our x is going to give us plus or minus 5. That is, our x is going to be affected at plus or minus 5. The same thing for y here. If we are to find the y-intercepts where x is equal to 0, we are going to see that this time our x is a 0. So we're going to have y squared equal to 25. So y squared is going to be equal to 25. Finding the square root of both of the number 25, we are going to obtain plus or minus 5. So as you can see, x is at plus or minus 5. Y is at plus or minus 5. So that's actually a circle that you're having. So you can draw your circle direct, then you can label or write the intercepts later on because you know this is going to be a circle. So that's at 0 here. X is at plus 5 or at minus 5. Y is at plus 5 or at minus 5. So this is plus 5. This is minus 5. So this is the graph of x squared plus y squared, which is equal to 25, which is representing a circle. All right, so that was question 1.2. On question 1.21, we are given, is this graph x squared plus y squared is equal to 25 a function or a relation? All right, so this is not a function, it's actually a relation. So a circle represents a relation in this case. Okay, so we've got infinity values in this case. So that's actually a relation. All right. Then we are given, is this graph symmetrical about the y-axis? Is it symmetrical? Okay, if you are to check here about the y-axis, if you divide like this, it divides your graph into 2 equal parts. So it's actually symmetrical. So that's yes. Even about the x-axis is also symmetrical. So that's a yes in this case. So that one is yes, it's symmetrical. 1.3, make a neat sketch of 2 functions. Okay, the function of y is equal to log x base e, and the function of y of x is equal to, okay, on the same set of x's. Again, 6 marks for that. So guys, you see this question was referring you back to mathematics N3, sketching of graphs. All right, so anyways, let's see how we are supposed to sketch these 2 graphs that you're given on the same axis in this case. So we were given the graph of y is equal to the logarithm of x in base of e. The logarithm of x in base e, that's a ln. So here we are given ln x. So the question is simply sketch the graph of ln x. So if you know your graph, guys, you do not have a problem. We know that the graph of ln x is this way, which passes through a point where x is equal to 1 in this pen like this, okay, where this is equal to 1. So this is the graph of y is equal to ln x. But as we are given this as log x base e, so I'm just going to write this log x base e, but we know that it's for ln. All right, so that is what you have. We move on to the second graph. The second graph was x is equal to y, the logarithm of y in base e. If you are to check, it's given in terms of x, which is very, very difficult for us to sketch a graph when x is the subject. So let us make y the subject. We know that if I am given a log form, the logarithm of a in base of b, which is equal to c, I can write this in exponential form where a is equal to b to the exponent of c. So that means I can change this to make y the subject because y is same as a in this case. So that means y is equal to the base to the exponent of c, b to the exponent of c. So the base in this case is e to the exponent of our answer, which is x. So here the question is simply asking you to sketch the graph of y is equal to e to the exponent of x. So you see, if you know the graphs, guys, we know this graph of y is equal to e to the exponent of x. It tends to approach to 0. Then it passes through the point where y is equal to 1 like this. So it's actually an inverse of the other graph that we drawn before. So this passes at 1. So this is the graph of y is equal to e to the exponent of x. But as we are given this as x is equal to log y in base of e, you write the same way you're given your question, but you know that you are drawing the graph of y is equal to e to the exponent of x. So they are just trying to hide the normal graphs that we are used to. They are just hiding it. Okay, so that was our question 1. 20 marks for that on your graphs, just to know how to simplify or to sketch graphs. All right, question 2. 2.1, we are given to simplify and express the answer in rectangular form. So this is complex numbers, a rectangular form. All right, if we are to check here, it's already in rectangular form, but for us to raise this to the exponent of 3, it is going to take us a lot of time. So what can we do? All right, let's check here. Let's just have this question aside. Let me just remove everything. All right, so this is question 2.1. All right, so on question 2.1, we were given that z is equivalent to -4 minus j3 to the exponent of 3. Okay, it is easier for us if we are to simplify this in polar form. Then we convert our answer back to the rectangular form. All right, we know that in rectangular form, z is equal to a plus or minus jb like this. That's our rectangular form. Then in polar form, z is equivalent to r cis theta, or it can be given as r angle of theta like this. So if you are given an exponent, it's best to solve in polar form. Why? If I am given r cis theta like this to the exponent of n, I can simplify in polar form, which is r to the exponent of theta cis n theta like this. That means it's easier for me to simplify an exponent in polar form. Even if you're writing this way, r angle of theta to the exponent of n is equal to r to the exponent of theta n theta like this. So we are supposed to convert this to polar form, of which you can first cross-check with your calculator. Okay, so our z, which is -4 minus j3, is in rectangular form, like this format. So we are supposed to convert this to polar form first so that we can solve this way. Then we convert back to Cartesian or to rectangular form. So before you can convert, you can check your answers first on your calculator. Let me just share the whole of the screen so that you can see how do you do it on your calculator. So on your calculator, you can change this. You can, you want to change to polar form. So it's a shift polar form. You go to this pole here where it's written pole. That's polar form in this case. So it's a shift to polar form like this, okay? Then you insert your values. It's -3, -4 followed by -3. So that's -4 like this. So to separate your numbers, it's shift, you use this comma here, shift, you use this comma, separated by -3 like this, you close your bracket, okay? So answer Okay, so it gives you the answer in polar form. Remember, in polar form, there is r and theta. So our answer in polar form is supposed to be r is equal to 5, as we are given here. R is equal to 5. So in polar form, our r is 5. So it's going to be 5. Angle of, we are also given the angle here, 143,13. So it's minus 143,13. So it's minus 143,13 degrees. Okay, so this is what we have in polar form. But how are we supposed to convert without a calculator in this case? How are we supposed to convert this to polar form? Okay, we can draw our Argand diagram, which shows the relationship between the imaginary part here and the real axis in this case. So we are going to have our real axis and the imaginary. So according to the real, it's a negative, imaginary, it's a negative. So you've got -4. So it is going to be in the third quadrant. Real, it's negative, imaginary, it's negative. So it's going to be in the third quadrant, where this is -4 and this is minus J3. All right, for the imaginary. So this is going to be your resultant, and this is going to be your alpha that you are going to use to calculate the theta. So theta is the angle taken from the real axis to this point, which is this angle. So this is going to be your theta. Or you can use this one from this point up to this point. This can be your theta. You can choose any of these two, all right? So according to your calculator, the answer that you're given is for this one. All right. If you want to calculate this one, I'm going to show you how you can calculate that one. All right. So R here is the resultant, which is taken from the square root of -4 squared from your Pythagoras theorem, -4 and -3 plus -3 squared. So this is going to give you 5. Then you calculate alpha, the angle inside of the triangle. So your alpha was supposed to be arctan theta, arctan opposite over adjacent. So it's opposite over adjacent. That's -3 over -4. So this is going to give us 36,869 and so forth, which is going to be 87 degrees to, if we try to round off to 3 decimal places, it's going to affect this to a 7. So now the theta, depending with where you are taking it from, if you take this one, the positive angle, your theta is going to be 180 degrees for a straight line plus the alpha. It's in the third quadrant. You add the alpha, which is you add 38,7. You find your answer. Or if you work with the negative angle, which is this one from this point up to this point, your theta is going to be alpha minus 180. So it's going to be alpha minus 180, which is theta. It's alpha, which is this reference angle of 36,87 degrees minus 180 degrees. This is the one that is going to give us -143,13 degrees. But not to say the 180 is not part of, it's part of our answer. We can even use that one, the 180,87. So I want you to use this one. You are going to obtain here 216,87 degrees. So on your calculations, I want you to try to work this one and see if you're going to have the same answer with the one that I'm going to use when I'm using this one. All right, that is the one that I got from the calculator. All right, so you can obtain the same answer actually. So remember, our purpose is to convert to polar form, which is this answer. That is the one that we got, and is the same that we're obtaining. This is our theta, this is our r. So as you can see, we are obtaining the same answer. So now we can simplify, because our z, which was equal to -4 minus J3 like this to the exponent of 3, is now equal to this in polar form, which is 5 angle of -143,13 to the exponent of 3 like this. This is where now you can apply the law that I was indicating to say, a number in polar form raised to a certain exponent, the exponent will affect the resultant and also multiplies the argument, which is the theta. So meaning to say 3 is going to affect this in our exponent. So this z is going to be 5 to the exponent of 3 times the 3 times this angle, of 143,13. So you multiply by 3. So if you multiply, if you simplify, z is going to give us 3 to the x, 5 to the exponent of 3. That is 125 angle of, if you multiply this, is going to give us negative 429,39 degrees. So if you are using this angle of 216, we are going to have different answers on the angle here, but they are the same. In which sense, if we convert back this to rectangular form, we obtain same answers. That is the idea. So take note that your question here is asking you to leave the answer in rectangular form. We are asked to leave our answer in rectangular form. So we are supposed to convert back this, our final answer, to rectangular form because it is in polar form. So therefore, our z in rectangular form, remember that z from polar form of r angle theta, it is going to be r cos theta plus rj cis theta, rj cos theta, or you can use I in this case, or you can use j. So it's going to be rj sine of theta, or you can use your calculator direct. So I want us to use the calculator first, then we check with our final answers in this case. So how do I convert now back to rectangular form? All right, so let me show you. Let me show you the screen here, everything. All right, so this time you want to convert to rectangular form. So it's a shift rectangular here, rect on minus shift rect like this. You use these values 125 as it is. So it's 125. You separate comma. So it's a shift. You use this comma here. Negative 429,39 like this. You close the bracket is equal to. So it gives you x, which is in what? In a rectangular form. So this is your x, which is this r cos theta. So your z in this case was going to be 44,000 and so forth. So your z, okay, let me write it here. So our z is going to be 44. That is our real axis in this case. Then y is representing the imaginary. So y, let's move our point here. Y is equal to 116,999 and so forth. So if you round off, this is going to be 117. So it's minus 117. So this is going to be minus j 117. So this is your answer that you're asked in what? In rectangular form. But as we are supposed to do it this way, we are supposed to show this working. So which means your z in this case is going to be r cos theta. That's 125 cos of theta, which is minus 429,39 degrees, plus rj sine theta. Our r is 125 times j sine of theta, which is sine 429,39 degrees. All right. So what you're going to do is to simplify each. Make sure that your calculator is in degrees. So 125 cos minus, so this is going to be in a bracket on your calculator. So it's going to be 44 comma something, which is going to be 44 minus, this is going to give you a negative. So it is going to be negative support 117 comma 116 comma, which is going to be j 117, just like the one that we had here. So this answer is going to be the same even if you used this as 216,87, your theta, you are going to obtain the same answers. Okay, so that was our z in rectangular form. So take note, our answer is supposed to be in rectangular form. All right, so let's check the other part of the question in this case, which is on question 2.2. We are asked to simplify. Okay. Let me just audit. Okay, here. We are asked to simplify in this case. These, we are not given even to say in polar form or in rectangular form. So you can leave in any format of your choice in this case. Okay. So for me, it's best to leave in polar form because okay. Okay. Let me write it down so that you can see. Why am I saying it's easier for me to leave this in polar form? We were given here 3 angle of 30 degrees by 4 cis 40 degrees. in this case, everything over 6, and this is cos 20 degrees plus I sine 20 degrees in this case like this. All right. So remember, I always, this is to simplify. These guys, they just play around with us. This format, 3 angle of 30 and the 4 c-spot is the same. They're just writing the same thing. So we can even change this to same format to say this is same as a 4 angle of 40 degrees like this. All right. Then we move on to this one. If we multiply this part here, if we multiply by 6, this is going to give us 6 cos 20 degrees plus 6I sine 20 degrees, which is taken from the format that I talked about before, r cos theta plus RI sine of theta. We say this is equivalent to R angle of theta. So as you can see, it simply gives us R here, which is a 6 and 6. And we've got sine and cos, which means the theta is our 20 degrees, the R is the 6. So this here is same as its 6 angle of 20 degrees. That is what it means. All right, so meaning to say, we were supposed to multiply 3 angle of 30 degrees times 4 angle of 40 degrees. In this case, you write in the same format. If you want to use cis, you work with cis here. I'm just going to use this angle, and this gave us 6 angle of 20 degrees. All right. So remember that in polar form, when you are multiplying, you multiply the numbers together, the angles you add, meaning to say R angle of theta, if it is R1 theta 1 times R2 theta 2 like this, you multiply the numbers R1, R2, then the angles you add theta 1 plus theta 2. All right, so this was going to give us 3 times 4, which is 12, angle of 30 plus 40, which is going to be 70. So you add the angle, so that's angle of 70 in this case. Everything over 6, angle of 20 degrees. This time you are dividing. So if you are dividing, you divide the numbers together, the angles you subtract in polar form. So meaning to say 12 divided by 6 is going to give us 2 angle of, you subtract the angles, that's 70 degrees minus 20 degrees in this case. So this is going to give us 2 angle of 50 degrees. If you are using cis, it is going to be 2 cis 50 degrees like this, depending with what you are using. Okay, so like we are not told that leave your answer in rectangular or in polar form, so we can just leave your answer in polar form than to now start converting. Already we are having our answer, now we want to start to convert these values and so on, so that can even end up making errors there in our conversion. So it's best for you to just leave it like that. All right, so these are the typical questions, guys, that you have. So that was our question 2. Let's check the other part, which is on question 2.3, to determine the value of x using Cramer's rule. All right, Cramer's rule. All right, so let's see our equation. Let me just try to remove this part so that we can properly see how our equation was presented in this case. So we were given all right, it's just that the fractions and so forth, but it's actually nothing at all. So this is question 2.3. So this was given as 1 over x plus 2 over y plus 1 over z, which is equal to 2. And also we are given 3 over x minus 4 over y minus 2 over z in this case, which is equal to 1. And also we're given 2 over x plus 5 over y minus 2 over z, which is equal to 3. All right, so if you check, we've got a certain formula that we are given, which we are not used to. So it is best for us to write this as 1 over, like 1 over x like this, 1 over y like this, 1 over z, so that we can properly see what is happening in this case. So if we are to write this in that format, that means this is going to be 1 times 1 over x. So it is going to be 1 times 1 over x like this. Plus, there is a 2, so it is going to be 2 times 1 over y like this. Here we've got 1 and 1 over z, so it's going to be plus 1 times 1 over z, which is equal to 2. Here, the same thing, 1 over x, 1 over y, and so forth. So we are going to have 3 times 1 over x minus 4. So this is minus 4 times 1 over y like this. For z, we do the same thing, minus 2 into 1 over z, which is equal to 1. We do the same here, 1 over x, 1 over y, 1 over z. So we're going to have 2 times 1 over x plus 5 times 1 over y, in this case, minus 2. So there's minus 2 times 1 over z, which is equal to 3. So we can see that we have got 1 over z, 1 over x, 1 over... So we are going to calculate just like the normal way. To calculate the value for 1, we are calculating 1 over x. From 1 over x, therefore, we can calculate x just like that. Okay, so that was the trick part of this question. So if normally we say to find x is the determinant with respect to x over the determinant of constants. This time it's no longer x, it's 1 over x. So meaning to say to find 1 over x, it is going to be the determinant with respect to 1 over x, which is not x, but 1 over x, over the determinant of constants. That is our Cramer's rule in this case. So we are going to find the determinant with respect to 1 over x in this case, whereby the determinant with respect to 1 over x, remember, that is a condition where we close a part where there is 1 over x, this part here. And if we close this part, we replace with the constants. So this is going to give us the constants 2, 1, and 3. So this is going to be 2, 1, 3. The rest, it remains as it is, which means we've got 2, minus 4, and 5. So that's 2, minus 4, and 5. Okay, we move on to z. This part of 1 over z, we have got 1, minus 2, and minus 2 like this. So we determine our determinant. So as for me, it's best for me to just use that one for signs, plus and minus and plus, where the determinant with respect to 1 over x is going to be plus 2. So remember, plus 2, you close the row and column where there is this 2. Okay, I'm using this row here. So I'm going to close the row and column. So if you close this column where there is 2, you remain with this part here of negative 4, negative 2, 5, and negative 2. Okay, we move on to 2, affected by minus. So it's minus 2, determinant of, we close the row and the column. So if we close this column, already the row is closed. You remain with 1, 3, minus 2, minus 2. So that's 1, 3, minus 2, minus 2. Okay, we move on to 1. It's affected by plus. So it's plus 1. We find the determinant according to this one. So if we close the row and the column where there is a 1, in this case, we are going to remain with 1 minus 4. So that's 1 minus 4, 3, and 5. All right, so that's it. We have the determinant with respect to 1 over x. So that is going to give us, remember that the determinant is the product of the major diagonal minus the product of the minor diagonal, which means we are going to affect the major diagonal in this case, which is the product of negative 4 and negative 2. Then we subtract the minor diagonal, which is minus 2 and 5. Okay, so the product, that means you multiply. So this is going to be 2 into, if you multiply minus 4 times minus 2 minus, so what I'm saying is minus 4 times minus 2. That's our major diagonal. Minus the minor diagonal, which is minus 2 times 5 like this. Okay, this is going to give you 18. So you do the rest. Minus 2, you do the same here. 1 and minus 2, minus 3. Minus 2 and 3, we are going to obtain 4 in this case, plus 1. We do the same, 1 and 5. 3 and minus 4, we subtract. This is going to give us a 17. So that means the determinant with respect to 1 over x in this case is going to give us 45. In this case, I'm obtaining 45. Okay, so I have the determinant with respect to 1 over x. We move on to another condition, this time finding the determinant with respect to the constants. So this one is for the constants in this case. All right. So for the determinant with respect to constants, so that we do not have our values away, we are closing this time. These are the constants, so which means we're just taking the left-hand side as it is. All right. So this is what you're going to have, the determinant with respect to constants. For the x, we are going to take everything as it is. That's 1, 3, 2. All right. So this is going to be 1, 3, 2 as it is. There's nothing that you're substituting. 1, 3, 2. We move on to the part of 1 over y. So this is 2 minus 4 and 5. So that's 2 minus 4, 5, 2 minus 4 and 5. We move on to 1 over z. This is 1 minus 2 minus 2. So that's 1 minus 2 and minus 2. So this is the one that you're going to use in this case. So just like what we did previously, our determinant plus, minus, plus, I'm going to work with the this top row in this case. So that means my determinant with respect to the constants, if I am to close the part of 1 here, we close the row and the column where there is 1, we remain in this case, that's plus 1 into the determinant of, we are going to remain with minus 4, minus 2, 5, and minus 2. We move on to 2 is affected by a minus, so it's 2 times minus, which is minus 2. We close the row and the column where there is this 2. So if we close this column, we remain with the 3, minus 2 here, 2 and minus 2, because that column is closed. Okay, we move on to 1. 1 is affected by a plus, so it's plus 1. We do the same. We close the row and the column where there is this 1. So we're going to remain with 3 minus 4. So that's 3 minus 4, 2, and 5. So that is what you're going to have. So determining the determinant is not going to change. We're still having the same concept of affecting the major diagonal. We multiply these two. We subtract these two together. Okay, so that is going to be 1 times, if you multiply properly, that is going to be 18 minus 2 here times, you do the same, 3 and minus 2, 2 and minus 2. We are going to obtain minus 2 in this case, plus 1, 3 and 5, 2 and minus 2. This is going to give us a 23 in this case. All right, so that's 23. So if you add everything, this is also going to give us a 45. Okay, so this was going to give us a 45 in this case. So the question is, to find x, we are now back to our formula. 1 over x is equal to the determinant with respect to x, to the determinant with respect to 1 over x, which is the determinant with respect to 1 over x, which is 45. So that's 45 over the determinant with respect to constants, which is 45. So 1 over x is going to be 45 over 45. That's 1. So it's 1 over 1. So you can cross multiply to find x. X times 1, that's x is equal to 1 times 1, which is 1. So our x in this case was going to be a 1. Okay, so that is how we could have calculated our x in this case using 1 over x. We end up having our x because on the equations we can have it as 1 over x, not as x direct, because we separated. This is 1 over x, 1 over x. Okay, so that was our question, having 7 marks for that. Okay, then we move on to another question. So it was actually a repetition, again using Cramer's rule. Determine the value of x and the value of y. So that's question 2.4 that we are having a total of 5 marks. Okay, so I'm just gonna write this aside so that we see how we're supposed to attempt this one. So question 2.4, we were given 2 simultaneous equations here with 2 unknown values. That is x plus 2y is equal to 4 as our first equation. Then also 5x plus 3y. Okay, so this is 3y, which is equal to 1 as our second equation. So we know that from our Cramer's rule, to find the value of x, we are going to use the determinant with respect to x over the determinant of constants. For y, we do the same thing, the determinant with respect to y over the determinant of constants. All right, so that means we can calculate our determinants here. All right, So let's simplify the determinant with respect to x. It means in place of x, this x here, we close this, we replace with the constants, which is 4 and 1 in place of x. So this is going to be 4, 1. But for y, it is going to remain as it is. You take the coefficients of y as they are, +2 and +3. So this is 2 and 3. You determine your determinant. So just like the previous case, we said determinant is the product of the major diagonal minus the product of this minor diagonal. So that's 4 times 3, which is 12, minus 1 times 2, which is 2. So this is going to give us 10. So the determinant with respect to x, that's 10. We move on. We do the same thing. We calculate the determinant with respect to y in this case. In place of y this time, you substitute the constants, which means x is going to remain as it is. This is x, which is same as 1x. So I have got 1 and 5. So this is going to be 1, 5. But for y now, I'm substituting the constants, which is 4 and 1 like this. All right. So that is going to give us the determinant for y in this case. Applying the same concept like previously, it's going to be 1 times 1 minus 4 times 5. That is going to be a negative 19 because that's 1 minus 20, which is negative 19 in this case. So the determinant with respect to y is negative 19. We move on to the other part. We find the determinant now with respect to the constants, where now we are not substituting anything. The constants, they are out. So we are going to have 1 versus 5. So we've got 1 and 5. For y, we've got 2 and 3. So this is 2, 3 like this. So that means our determinant with respect to the constants, that's 1 times 3 minus 2 times 5. So that is 1 times 3, which is 3, minus 2 times 5, which is 10. So our determinant with respect to constants is going to be a negative 7. So with this information, it is enough for you to have the value of x and the value of y, since we said x is equivalent to the determinant of x over the determinant with respect to constants. So we are going to have 10 for the determinant of x over the determinant of constants, which is negative 7. So that is going to be negative 10 over 7. Or as a decimal, that's negative 1,429, okay? For y, we are going to have the same thing. That means y is going to be equal determinant with respect to y, which is negative 19 over the determinant of constants, which is negative 7. So that is going to be 19 over 7, or it can be a decimal, 2,714, and so on. Okay, so that is what we're supposed to have in this case. For this one, it was just a repetition, as we saw, same method, but just this time we're dealing with 2 unknown values. So that was question 2, having a total of 20 marks in this case. Okay, so let's check what we have on question number 3, which is on trigonometry. In this case, also having a total of 20 marks. The first part was to simplify. Okay, this is simplification. So we are given 3.1 to simplify sine squared x into 1 over 1 plus cos x plus 1 over 1 minus cos of x. Simplify, 5 marks for that. Okay, so let's see how we can simplify. Just like our normal addition and subtraction of fractions, we can also do the same thing, combine this to a single fraction. That means we are going to have sine squared x into, if we combine, that means we have to find the LCM of these two, which is 1 plus cos x and 1 minus cos x. So this is going to be 1 plus the cos of x into 1 minus the cos of x, like this. Okay, so on your division, remember, on your addition, you're going to divide your LCM to the denominator. So 1 plus cos x and 1 plus cos x will cancel, which means we remain with 1 minus the cos of x, which is multiplied 2 to 1 in this case. The same thing plus, in this case, if we divide our LCM to 1 minus cos x, 1 minus cos x and 1 minus cos x will cancel, which means we remain with 1 plus cos x multiplied to this 1. So it's 1 plus the cos of x in this case. All right, so this is what we have. From this stage, we can simplify further. That is, the sine squared of x is equivalent to expand the brackets 1 times anything, it remains as it is. So it's 1 times 1, which is 1. 1 times minus cos x, which is minus cos x. 1 times 1, which is 1. 1 times cos x, which is the cos of x in this case. Everything over. Let's take back to our identities, or from our difference of two squares. We know that a squared minus b squared is equivalent to a minus b into a plus b, which is the same condition 1 and 1. Cos x and cos x, one is adding, one is subtracting. So this can be taken back to a squared minus b squared, where a is 1 and our b is cos x. So this is going to be 1 squared, which is 1, minus b squared, our b, which is cos. So this is going to be cos squared x. All right. At this stage, we are going to simplify again further. Let's check on our fraction. Do we have anything that you can do on the numerator? Minus cos x plus cos x, this can cancel. All right, which means we remain with 1 plus 1, which is 2. So this is going to give us 2 over 1 minus cos squared x. If you have to take back to from your identities, we know that the cos squared of x plus the sine squared of x is equal to 1. So 1 minus cos means we transposed cos to the right-hand side, and we remained with the sine squared x, which is equal to 1 minus cos squared x. So it means in place of 1 minus cos squared, there is sine squared. So this whole part is equivalent to sine squared x. So at the end, these two can cancel because this is same as over 1. So from your multiplication, the denominator can cancel with the numerator. That means we are remaining with 2 in this case. So the whole of this simplification was going to give us a 2 as our final answer. That's it. Just like that. Okay. So that was our question, guys. And you're supposed to be very, very careful on this one, especially the sine squared. Make sure that you have it up to the final answer where you can cancel everything. All right. So that was our question 3.1. In this case, we've got a 3.2 where we are given our identities, not just identity, but ratios that we can actually simplify further. So we're asked again to simplify. So here we can just directly take our values. This is 3.2. We have got cosec 360 degrees minus x, of which cosec, we are not used to cosec, but we know that cosec of x is equivalent to the 1 over sine of x. Remember, sine, if we say 1 over sine is cos, so which means if it is cosec 360 minus x, it is going to be 1 over sine 360 degrees minus x, like this, okay? Times cot minus x. So this is going to be times cot. Also, we are not used to this cot, but we know that cot is cos over sine. So this is going to be cos of minus x, as it is, because it's cot minus x, over sine minus x, like this. All right. We move on to cos 90 degrees minus x. All right. So from your co-ratios, we understand that the sine of x is equal to the cos of 90 degrees minus x. So if I'm given cos 90 minus x, it's equal to sine x. So this whole part is equivalent to the sine of x, all right? Everything over sec 360, also sec, we are not used to this. We know that sec is 1 over cos. So if it is 360 plus x, it's going to be 1 over cos 360 degrees plus x, like this, all right? Times sine 180 degrees minus x, which is in the second quadrant. Remember, 180 minus x, that's our second quadrant from our cast concept. This is for sine, which is a positive. So our sine is going to remain as it is, as the sine of x, times tan squared 90 minus x in this case. Okay. We know that tan in this case, okay, tan 90 minus x is equivalent to cot, okay? Tan 90 minus x, tan 90 degrees minus x is equivalent to cot x. But if it is given as tan squared, so it means this is going to be cot squared. So cot squared, but we said cot is cos over sine, and this is a cot squared. So it is going to give us cos squared over sine squared from this 40 squared that we are now having. All right. So this is the first stage that was very, very important from that one. Okay. So now we can simplify. What can we do? Sine 360 minus x. Which quadrant are we talking about? 360 minus x is in the fourth quadrant for cos, and sine is a negative. So this is going to give us 1 over negative sine x. Okay. Times cos minus x is a negative angle which lies in the fourth quadrant, and in the fourth quadrant, cos it's a positive. In this case, it's negative x, but cos it's a positive. It's a quadrant for cos, so it is going to be positive cos x. Sine minus x in the fourth quadrant, sine is a negative because it's for cos, so it is going to be negative sine x. Okay, times the sine x that we are already given here. All right, everything over 1 over cos 360 plus x. 360 plus x, it means we have completed a revolution. 360 is a complete revolution. So plus x, we are back to the first quadrant. And in the first quadrant, everything is positive. So which means this cos is also a positive. So it's 1 over cos x times, in this case, this is going to be sine x times cos squared. All right. This one we could have simplified, but in this case already I've written, but we could have simplified the other part. All right. So this is the stage where we are now. So at this stage, we can actually simplify by canceling whatever part that is able to be canceled. In this case, like here, we've got sine x into sine squared, which is sine x, because this is same as like over 1. Like this one is same as over 1. So it can even affect to say sine x and sine x, it cancels with this sine x, which means we remain with a negative, but negative times negative, it's a positive. All right. So here also we are remaining with cos. Cos here, it's 1. Cos into cos squared, it is going to give us a cos x. All right. So if you check in the numerator, we are remaining with cos x over sine x. So this is cos x over sine x. In the denominator, we are remaining with also cos x over sine of x. So these two divided together, they are just the same. They can cancel. So this is going to give us a positive 1. So our answer in this case was going to be a 1, just a direct number, which is 1. Just look, guys, the steps that we had just to add up with a single number in this case. So most of these trig, that's how they are. You'll be given a complicated trig, which you have to simplify until you have a basic answer just like that one. All right. So that was what we had in this case. Let's check the other part on question 3.3. So question 3.3, we are now asked in this case to solve. So this was to solve for theta, and our theta is ranging from negative 180 up to positive 180 in this case. That's our interval in this case, negative 180 up to positive 180. So we are given that the 2 cos squared theta, this is 3.32 cos squared 2 theta plus cos 2 theta minus 1 is equivalent to 0. So in this case, we can solve, we can choose to let cos 2 theta to be equal to k so that we can solve it properly. So that means in place of cos 2 theta, I've got k. So this is going to be 2k squared plus cos 2 theta is k. So this is going to be k minus 1 is equal to 0. So I have a normal quadratic equation that I can actually solve for k the normal way that we do when solving equations. So that means here we can use our factorization method, or we can use our quadratic formula. Applying our factorization, if we multiply the first term to the last term, that's minus 2k squared. We need factors of minus 2k squared, which is in this case is 2k and minus k. So we are going to obtain this as 2k squared plus 2k minus k minus 1 is equal to 0. So group into 2, 2k is common. That's 2k plus 1. Factor out minus 1. In this case, it is going to be a positive. Here, it's going to be 2. It's not going to be 2k because we are dividing here. 2k squared and 2k, that's going to be k. 2k and 2k, that's plus 1. So to factor out minus 1 so that these two brackets will be the same, it's k plus 1 is equal to, or you can even use quadratic formula, guys. You solve using your quadratic formula. you find your values of k, still it's fine, okay? So here we are going to have 2k minus 1 equal to 0 in this case. So equating each of these brackets to 0, that means this bracket is equal to 0, so our k is going to be negative 1, or equating this bracket to 0, our k is going to give us a positive half in this case. All right, so remember that k, we introduced this in place of cos 2 theta. So in place of cos 2 theta, we are going back now in place of k to substitute our cos 2 theta to say that here we are now having k, which is equal to minus 1, and k, which is a half. So that means cos 2 theta is equal to minus 1, or cos 2 theta is equivalent to a half in this case. So this is what you're going to have. All right, so this is an equation of a trig where you can actually play around to find the exact values in this case. So if you are given a 2 theta like this, it means whatever answer that you're going to have, you're going to divide by 2. So taking an interval that we are given of theta ranging from minus 180 to positive 180 degrees, it means here we are going to find the reference angle in this case, which is taken from the arc cos. So if you use arc cos negative 1 in this case, or just arc cos 1, okay, just remove the negative, just arc cos 1, we are going to obtain a 0 in this case. That's a 0. So you're now asking yourself the quadrants where you have your cos being a negative. Which quadrants are we talking about where our cos is a negative? From the application of cast method, our cos is a negative in the second quadrant and also in the third quadrant. So in the second quadrant, we know this is supposed to be 180 degrees minus theta. This is supposed to be 180 degrees plus theta. So in this case, we are having an angle of 0 degrees as our reference angle, which is our theta that we are supposed to have. So meaning to say our 2 theta is going to be 180 minus theta, which is 180 minus 0. That is going to be 180. There's nothing that we have added. We move on to the other one. It was supposed to be 180 plus theta. So if we add a 0, simply there's nothing. So it is going to remain as 180. So to find theta, we divide by 2 by 2. So theta is equal to 90 degrees. Okay. But take note, we are taking from minus 180 to positive 180. So on the negative angles, remember, these are positive angles. Negative angles are taken now in this direction like this. So this is going to be our negative angle, or this one in this direction. These are now our negative angles. All right, so this is how we take the negative angles. So in the third quadrant, in terms of negative angle, it is supposed to be theta minus 180. In the second quadrant, in terms of the negative angle, it's supposed to be minus theta minus 180. But our theta is 0 degrees. So if we say minus 0 minus 180, it is going to give us negative 180. If we say theta minus 80, which is 0 minus 180, 0 minus 180 is minus 180. So which means we are going to have another solution in the negative where 2 theta is equal to minus 180 degrees. So if we divide by 2 by 2, also theta can be minus 90 degrees from cos 2 theta is equal to 1. But remember, we also have another solution where cos 2 theta is equal to a half. So we are going to take this now as another solution. Cos 2 theta is equal to half. We do the same thing. We find the reference angle just like previously. Cos 2 theta is equal to a half. So our reference angle that is equal to the arc cos of a half in this case, which is going to give us 60 degrees. But remember, there are positive and negative angles. So 2 theta is equal. So these angles, in the positive from our cast, we have got the first and the last quadrant. In the first quadrant, it is going to remain as the reference angle as it is. In the fourth quadrant is 360 degrees minus the reference angle, which is theta. So it is going to be 360 minus 60, which is 300. So also 2 theta is equal to 300 degrees. So from these, we can divide by 2 by 2. Theta is equal to 30 degrees. Divide by 2 by 2. Theta is also equal to 150 degrees if we divide by 2 both sides. So these are also the other values of theta that we could have determined. But these are for positive angles. What about for negative? We are now moving in the negative direction. So our 2 theta in the negative direction is going to be equal to minus 60 degrees. We divide by 2, so theta is going to be negative 30 degrees. Or in the first quadrant, where the angle is theta minus 360. So 60 degrees minus 360 is minus 300 degrees. We divide by 2, which is minus 150 degrees. So we're going to have our angles as minus 30, minus 50, 150, 30. Also, the other two that we determined, 90 and minus, all these were supposed to be our solution. As long our theta is taken from minus 180 up to 180, this interval that we are given in this case here, those are the solutions that we are supposed to take, because we are given that is supposed to be taken from minus 180 to positive 180. All right, so that was our question 3.3. Let's check 3.4. So 3.3, it was actually having how many marks? 7 marks. Okay, so that's why 7 marks is a lot. So that's why we have a lot of answers there. All right, 3.4, we are now given to prove that the cos of theta minus, the cos of 60 minus 45 is equivalent to this here. So this is back from your compound angle identities here. So taking from the left-hand side, we know that from our compound angle, we're supposed to have the cos of A times the cos of B plus the sine of A times the sine of B, of which in this case, our A is 60 degrees. So that's cos 60. Cos B, which is 45 degrees. The sign changes to a plus, so it's times sine 60 degrees times the sine of B, which is 45 degrees in this case. All right. So having this, we can apply our special angles. We know that from our special angles here, we've got 60 and 45. So from 60 degrees, we say this is 60. This is 30, so this is 1, 2, square root of 3. Then we have got the 1 for 45 and 45, which is 45. 45, this is 1, 1 square root of 2. All right. So if you are to simplify this, even with your calculator at this stage, the special angle does not make, because whatever you get from your special angle is the same as you get from your calculator. So you can even use your calculator at this stage, okay? So cos 60, that's 1/2. Opposite, adjacent of hypotenuse, that's adjacent of hypotenuse, 1/2 times cos 45, which was going to be square root of 2, 1/square root of 2. So 1/square root of 2 is going to give us square root of 2/2 from your calculator, plus sine 60, that's opposite over hypotenuse, square root of 3/2 times sine 45 is also opposite over hypotenuse, which is 1/square root of 2. So it is going to give us square root of 2/2. So in this case, we can multiply the numerator to the numerator. 1 times square root of 2, that's square root of 2 over the denominator and the denominator. 2 times 2, that is 4, plus square root of 3 times square root of 2. Remember that if you're multiplying sets, you multiply the numbers under the square root. So 2 times 3, that is 6. Everything over 2 times 2 in the denominator, which is a 4. So since the denominators are the same, there is 4, I can simply add the numerators together, which means I'm having square root of 2 plus square root of 6, which is same as what we were given from the right-hand side. In this case, we have managed to prove that this is equal to what we have on the right-hand side in this case. All right, so this was an application of compound angles in this case, where you are using your compound angles, okay? On question 4, determine the limit where we are given. All right, let's just check here what we are given in this case. That's question 4.1. We are given the limit where we have got the square root of x minus 2 over x minus 4 in this case, where we are limiting to x as approaches to 4. So if x approaches to 4, this is going to be 4, this is going to be 4. So square root of 4 is 2, 2 minus 2, that's 0/0. So we can apply our derivatives, differentiate the numerator and the denominator at the same time. This is same as x to the power of a half. So applying our limits, we can differentiate so that we can apply our limit again. So this derivative, we drop the exponent, remember, a x to the exponent of n. When differentiated, it's a n x to the exponent of n minus 1. So if we drop the exponent, it is going to be half x to the exponent. If we subtract 1, that's a minus half. Everything, okay, the derivative of 2, that's a 0, so there's nothing that you can have here. We move on to the denominator. The derivative of x, that is 1. The derivative of 4, that's a 0. So let's apply our limits now and check what is going to happen here. So as x approaches to 4, this is going to be 1 over 2 into 4 to the exponent of minus half. Okay, which we can simplify here. There's nothing that we are limiting, so we can have our final answer in this case, which is going to give us 1 over 4 as our final answer. All right, so there are so many ways that you can actually apply. If there is any other way, let us know, guys, in the comment section so that you can help others with your method of finding this. Okay, on question 4.2, we are now asked to differentiate with respect to x, okay, with aid of quotient rule. We are given what to use in this case. Apply or use quotient rule. So that is what you're given. So that is our question 4.2, where we are given that y is equivalent to tan x over the ln of x in this case, which you are also given in your formula sheet. So this is going to be ux and vx. So remember that from your formula sheet, we are given that the derivative of y with respect to x, when you are given ux over vx, it is going to give us, I'm taking direct as it is on your formula sheet, that's vx times the first derivative of ux minus ux times the first derivative of vx, everything over vx squared. So that means in this case, from the information that we are given in this case, our ux is the numerator in this case, which is tan x. So we must have its derivative as we are given from our formula here. There is a need for us to have the derivative. So the derivative of tan, remember tan, guys, that's sec squared. So this is sec squared x. We do the same thing for vx. Our vx is the denominator, which is ln x. And the derivative of ln x is 1 over x, okay? This one, you must know it, guys, or even you're given in your formula sheet, that's 1 over x. So now let's combine this back to our formula for finding dy dx from our quotient rule. It states that it's going to be vx. Our vx, it's ln x. So that's ln x times the first derivative of u. The first derivative of u is sec squared. So this is going to be sec squared x minus ux. Our ux is tan x. So this is tan x times the derivative of v. V with is 1 over x. The derivative of this is 1 over x. Everything that we have here over vx squared, of which our vx is ln. So this is going to be ln x, everything squared. Okay, so this is what we are having. You can simplify further if you want, but that's what you're going to have in this case. All right, sorry for that. So let's check the other part of the question. That's 4.3. Differentiate with respect to x with the aid of product rule this time, okay? So we are given to apply or to use the product rule this time. All right, we have got y is equal to ln x squared and ln squared x. Take note, these two, they are just a little bit similar, but they are not the same. So this is y, which is equal to, it was ln x squared, like this, the first one. Then the second one, it's ln squared x. These two, they are different. X is the one that is squared here. Here it's ln. All right. So this from our product rule, remember that we'll be given this as our ux and this as our vx. So the derivative of y with respect to x, I'm taking this formula direct as it is from your formula sheet. It's ux by the first derivative of v plus the derivative of v of ux by vx, of which here you can even interchange. You can start with this part or whatever that you want, because it's addition. Addition does not affect. All right. So we saw that from our information here, we have got ux in this case, which is equivalent to ln x squared. This is ln x squared, of which from your laws of logarithm, we know the exponent. You can drop that exponent, which is same as we've got 2 ln x like this. All right. So we need to find the first derivative now of this u in this case, which is the derivative of ln. Remember, it's 1 over x. So 2 times 1 over x is going to give us 2 over x. All right. We move on. This part is our v. So our vx in this case, it's ln squared x. This means that it's ln x squared like this. This is what it means. So in order for you to have the first derivative of vx in this case, we are going to find the derivative from our function of a function, the derivative of a function, which is going to be 2 ln x. We subtract 1 here, which is going to be 2 ln x. Then we find the derivative of what is inside, which is ln x. The derivative of ln x is 1 over x. So meaning to say, the first derivative of v is going to give us 2 ln x times 1 over x like this. Okay, so this is what we have. Let's take back this to our formula. So therefore, our dy dx is going to be equal to ux, all right? Our ux, we said, is 2 ln x. So this is going to be 2 ln x times the first derivative of v, which is this one that we got here. We got 2 ln x times 1 over x. This is what we got. Plus, we move on. The first derivative of u here is 2 over x. So this is 2 over x times vx. Our v in this case is ln squared x like this. Okay, so this is what you're going to have. So I want you to simplify and see what was going to happen. So this was a crazy question, because if you simplify here, we can multiply 2 times 2, which is 4, times 1 over x. So 4 times 1 over x, it's 4 over x. Then we move on to ln. This is ln times ln, just like x times x is x squared. So if you multiply ln and ln, it becomes ln squared. Plus 2 over x in this case, we've got ln squared x. Are you seeing that these are actually like terms that you're ending up with? You are having a condition of over x over x. So you can add 4 plus 2, which is 6 over x. So this is going to be 6 over x. The ln is going to remain as it is. So it's going to be ln x squared. What you can simply add is that part. These are how you can simplify your like terms in this case. Okay, so that was the question, guys. A very, very interesting, typical question. So that was a typical question, very, very interesting in a way that it was a play around of your derivatives, and also acknowledging the idea of logarithms also, or the application of exponents and logarithms, which is very, very important. All right, so that was question 4.3. On question 4.4, we are now differentiate with respect to x. All right, so as we know that to differentiate with respect to x, we are supposed to have these numbers in simplest form. So do we have these in simplest form? Okay, let's check. 1 over cosec. So we know that 1 over sine x, it gives us cosec x. So meaning to say 1 over cosec gives us sine. So it is going to be sine 3x in this case. So that's 4.4. We are not yet differentiating. We are just rewriting so that we can differentiate later on. So y is going to be, we said 1 over cosec, it's sine 3x. So this is sine 3x. All right. We move on here. We have got 1 over cot. Remember, 1 over tan is the one which gives us cot x. So meaning 1 over cot is a reverse. It gives us tan x. So this is supposed to be tan x in this case. Are we subtracting? Okay, we are subtracting in this case. So it's minus tan x. All right, minus tan x. We move on. E, we have got E in the denominator here. So we can take this on top. Remember, to remove a negative, it becomes a positive. We write it on top. So it's going to be square root of 2e to the exponent of x. All right. So that's square root of 2e to the exponent of x. So that's plus square root of 2e to the exponent of x. All right. Let's check the other part. Okay, this one is fine. Minus 6 to the exponent of x. 2 pi over p, everything is fine. We just rewrite that part as it is. So this is minus 6 to the exponent of 2x plus 2 pi over p, like this. Okay, so take note, the question is for us to find the derivative of y with respect to x. So dy dx is going to give us, remember, sine, it changes to cos. So this is going to be 3 cos. So it's 3 cos 3x. Okay, tan, it's sec squared. So this is minus sec squared x. What about the derivative of e? Remember that the derivative with respect to x for e to the exponent of f of x is the first derivative times e to the exponent of f of x, or you can use that one for ln e and so forth. Okay, so here we are going to have this as our constant, which is going to be the square root of 2. E is going to remain as it is because the first derivative of 1 here, it's 1 times square root of 2. So e is going to remain as it is. If you want, you can use ln e at the end, or you can even leave that ln e. It's not a problem. Then the derivative here of minus 6e to the exponent. So here we can take advantage of the derivative with respect to x of a to the exponent of f of x, which is the same as that one for e, which is the first derivative with respect to f of x times a to the exponent of f of x times ln of a, which is the one that I was saying for e, to say we can use ln e, but we can leave like that because we know that ln e is equal to 1. But for this one, we can't leave this. Okay, so here, this is our f of x, which is 2x. So the derivative of 2x is going to be 2. So that's minus 2. A to the exponent of f of x, where we have got our constant. We do not have a constant, so it is going to be 6 to the exponent of 2x times ln a. So it's times ln. Our a is the base in this case, which is 6. So this is going to be ln 6. All right. Then the derivative of 2 pi over p, we do not have x. So the derivative of this is like a constant. So it is going to give us a 0 in this case. All right. So that was our question 4.4. Having a total of 5 marks just to find these derivatives. On question 5 or 4.5, we are now given a consideration to find the point of inflection from this cubic equation that we are given. Find the point of inflection with the aid of differentiation. So we know that for the point of inflection, the second derivative must be equal to 0. So we are given our f of x in this case as 3x to the exponent of 3 plus 9x squared plus 3x plus 7. So for point of inflection, we are saying the second derivative with respect to x must be equal to 0. So that means we are supposed to work the first derivative with respect to x, which is going to be 3 times 3, that's 9x squared, we subtract 1. 9 and 2, which is 18, we subtract 1, this is going to be 18x. For 3x, it is going to be 3. 7 is a constant, so that's a 0 in this case. So we have got our first derivative. We find the second derivative, that's 9 and 2, which is 18x. 18x, which is 18. 3 is a constant, so that's a 0 in this case. So since the second derivative must be equal to 0, that means 18x plus 18, which is our second derivative, must be equal to 0. So by this, we can calculate the value of x at the point of inflection in this case, the value of x at the point of inflection in this case. All right, so that's at this point, we are going to transpose 18 to the other side, which is going to be negative 18. Divide by 18 by 18. So we have got our x at the point of inflection, which is negative 1. All right, so that was the value of x. So the question was not asking us to determine exactly the point of inflection, but the value of x. at the point of inflection, calculate here the x coordinate of the point of inflection. If it was a point, you substitute the value of x back to the equation, you determine the value of y. Now it's a point xy. Okay, so that was question 4 on integration, on differentiation, sorry. Then we move on to question 5, which is on integration, having 20 marks again. All right, so question 5.1, evaluate the integrals that you are given with respect to t. Okay, so this dt means with respect to t. And we've got the limits in this case from 0 to 1. Okay, so that's question 5.1. Let's see how we're supposed to answer this typical question. So we're given the integral of t squared plus 2t plus 1 with respect to t. So remember that on integration, you add 1 on the exponent, then you divide by 1. So this is going to be equal to t to the exponent of 2 plus 1, that is 3. We divide by the new exponent, plus on 2t, this is same as to the power of 1. So you're going to add 1, which is going to be 2t to the power of 1 plus 1, which is 2 over 2. So the 2 and the 2 can cancel, which is going to give us t squared plus 1. It's a constant. So if you integrate, it is just going to be t. Then we have got our limits, in this case, from 0 up to 1. So how do you apply the limits? You substitute the upper limit minus the lower limit. The upper limit, which is 1, the lower limit, which is a 0. So in place of t, we are going to substitute 1, which is our upper limit. So it's 1 to the power of 3 over 3 plus 1 to the power of 2 plus 1 in this case. We are substituting 1 in place of t, minus on the lower limit, you substitute a 0. So in place of t, if you substitute, as you can see, guys, it is going to give us a 0 in this case. All right. So, but you're supposed to substitute each and every point if possible. So here we are going to obtain 7 over 3 minus a 0, which is going to be 7 over 3. All right, so that was the value, or you can write this as a decimal, depending with with how you want to simplify these guys. All right, so that was our question 5.11. We move on to question 5.12, where we are now given again to integrate, that is sine of 2 theta over cos 2 over cos theta. In this case, that was 3 marks for that. Okay, so 5.12, the integral of sine 2 theta over cos theta with respect to theta. So you know that from our identities, sine 2 theta is same as 2 sine theta cos theta. So this is what we are going to have, everything over cos of theta with respect to theta. So cos theta and cos theta can cancel. That means we are going to remain with 2 sine theta. Remember that the integral of sine, it's a negative cos. So this is going to give us negative 2 cos, or even you can check from your formula sheet. We have got our integrals here. We are given that the integral of sine, that's negative cos. So this is going to give us a negative cos of theta. But take note, there is a 2 that we have here. So it is going to be negative 2 cos theta plus the constant of integration in this case, which is c. All right, so that is what we have in this case, 5.12. 5.2, simplify the following integral, just like what we had on derivatives. This time, we are going to apply the same concept, integrating each term that we are given. So we are supposed to integrate each term, and all these terms, they are in simplest form. So we're going to integrate direct. There's no need for us to even rewrite anything here. So remember, on our integrals, we say we add the power on a constraint like this. We are going to add a 1 in this case. So if we add a 1, this is going to be minus 2 plus 1, that is minus 1 in this case. So it was going to give us 2x to the power of minus 1 over minus 1, which is going to be minus 2 over 1, because 1 over x, this x to the power of minus 1, it's 1 over x. So it is going to be minus 2 over x. This is what you're going to have in this case. All right, so we are going to obtain minus 2 over x in this case. All right. We move on to the other one, 3x to the exponent of minus 1. Take note, we can't integrate this, so we write it as over x. So x to the power of minus 1 is same as 1 over x. So it's same as 3 over x. And the integral of 1 over x is ln x. So this is going to be plus 3 ln x. All right, we move on to tan. The integral of tan, we are also given on our formula sheet here that the integral of tan is ln sec x. So this is going to be ln sec x in this case. So we're going to have plus 4 ln sec x in this case. All right. Then we move on to the integral of sec squared. So we do not have this integral, but we can change because we know that integration is a reverse of differentiation. So if we differentiated tan and we got sec squared, it means if we integrate sec squared with respect to x, it is going to give us a tan x. So our answer in this case is going to be plus 3 tan x, because we've got a 3 in this case. It is going to be 3 tan x plus the constant of integration. Okay, so this is what we're going to have as your final answer in this case. All right, 5.3, still on integration, we are given sketch the graph of x is equal to y squared. Clearly indicate, all right, so just like the previous graph that I told you that it's difficult for you to sketch a graph when it is written x is equal to. So make y the subject in this case. So we are given that x is equal to y squared. So you can simply make y the subject by putting the square root both sides. That means y is equal to square root of x. Guys, the square root of x can only be a positive. We can't have x being a negative. So if you know this graph, you can actually sketch, or you can assume to say a square root of any number gives me plus or minus. So if I'm finding square root of 0, square root of 1, square root of whatever number, it is going to give us a plus or minus, meaning to say our graph in this case was supposed to be like this. So this is the graph that we are supposed to have in this case. But as we are not writing this graph as y is equal, we are writing the same way that we are given on the question. It's x is equal to y squared. But we know that this is the graph for y is equal to square root of x. All right. So this is what you are given. This is your x and this is your y in this case. If you are to take, we are given that we are supposed to indicate the area included between the curve, which is x is equal to y squared, and the x-axis. All right. So we need this between the curve, all right, and the x, which means we are talking about any curve in any region in between. And also x is equal to 0 and y is equal to 2. So the graph of x is equal to 0. That is the graph, that is the y-axis. In the y-axis, x is equal to 0. So it's supposed to be bounded also by the y-axis. And the line of y is equal to 2, where we can say, okay, this is where we have our 2. So the line of y is equal to 2 in this case is going to correspond at a certain point where you can even substitute here that x is going to be at 4. So x is going to be at a point of 4 in this case. So in this case, the region that is bounded by the curve, this is our curve. In this case, this is your curve and the x-axis. So which means it was going to be either this way, because this region, guys, is covering this question, guys. It's included between this curve and the x-axis. The line x is equal to 0 and the line y is equal to 2, which is this one. So which means we are referring to this part here. So which means we can include this point here or this region that we are given in this case. So meaning to say that was going to be our area, or it was going to be this one, because there are two possible regions, this region or this region. So this person was not straightforward. They wanted to give us another point, because if it is the whole of this region, therefore I'm just calculating 4 times 2, I have the total area. But in this case, we can take it according to this region, which means we can have our representative strip in this way. All right, on 5.3, to calculate the magnitude of that area now. So as we know that the area is taken from the integral, so that's 5.32. So our area is going to be the integral with respect the integral of y with respect to x with the limits a and b. So if you're using this, or if you're using from 0 to 2, then it is going to be x with respect to y. Okay, so that is what you're going to have in that case. So meaning to say, if we are having y in this case, this is going to be, remember that we said y is equal to square root of x, of which square root of x is same as x to the exponent of a half. So that means we are having the integral of x to the exponent of a half with respect to x from 0 to 4. So this is from 0 to 4. So our area, based on this, it is going to be, if we add a 1 here, we are integrating, so we add a 1. So it is going to be x to the exponent of 3 over 2, everything over 3 over 2 with our limits 4 and 0 in this case. So you can even substitute your values at this stage, depending with your simplification, guys. Someone can actually determine the value at this point direct, okay, which is going to be 16. All right, what I'm trying to say, okay, like this. If you are to substitute, this is going to be 0 here. So our area is going to be, so starting with 4 first, before this 0, we're going to start with a 4. So this is going to be 4 to the exponent of 3 over 2 over, then we've got 3 over 2 in this case. Whatever that you get, we divide by 3 over 2 minus, when x is a 0, so that's 0 to the exponent of 3 over 2. Whatever that we get, we divide by 3 over 2. So if you are to simplify this, you are going to see that your answer or your area is going to give you 16 over 3 square units, which is area. So area is actually measured in square units. All right, so depending with the region that you're talking about or the region that you're given. So that was what you're going to have 4 marks for that, calculating the area that is bounded by that interval or region that you're given. So if there is any part, guys, that you're not understanding or any error that you have made, please let us know on the comment section so that we can work on that question together again to see how we're supposed to have it in a correct way. But for now, that's what we have for Mason African motives till we meet again.